In this class, I am going to discuss about minimization of Boolean functions. To implement a Boolean function with a lesser number of gates, we have to minimize the literals or we have to minimize the variables and their number of terms. The Boolean variables are either in complemented or uncomplemented form, and the terms are arranged in one of the two standard forms of Boolean functions. They are called sum of products and product of sum. Okay. First, we'll discuss what is meant by sum of product form. The sum of product form expression contains two or more AND forms which are odd with together. Each AND term, nothing but a product term, consists of one or more variables appearing either in a complemented form or uncomplemented form. Okay, now, so let me explain this through an example. Okay, so first I'm going to talk about sum of product. So first sum of product. First we write sum and A B C bar it is a product means, and B bar C it is a product. A B is a product. What is meant by product? So AND gate, no? What is mean product? AND gate. Look at here. A B C bar means A into B into C bar and B bar into C and A into B. Okay, now. So first sum of product. First we should write sum of product. So what is the sum here? This is a sum. What is the product here? Is a product. Okay, now which includes AND gates B bar C and AB. So this is nothing but a sum of product. Okay, now. So next one is what? Product of sum. The product of sum form expression contains two or more OR terms. So two or more OR terms. So this is OR term. Okay, now this is a OR term which are ANDed together. So which are ANDed together means this is an AND gate. It is an AND gate. Okay, now it is an AND gate. Okay, now ANDed together to form a POS expression is product of sum expression. Each OR term contains one or more variables appearing either in complemented form or uncomplemented form. Each OR, so this is OR, for example, A plus B plus C. Each, okay, na? Each OR term contains one or more variables appearing. So this is an uncomplement form. It is uncomplement form. It is a complement form. Okay. Let me explain through an example. Okay, this is example I'll take here. Okay, now we are talking about product of sum. Okay, na? So first product of sum means take a product here and take a product here and take a product here, and this is nothing but into relation. Okay, na? So product of sum nothing but what? A plus B plus C bar, and so this is a sum. Okay, na? And this is A plus B bar. Now, okay, it is a sum. Right, it is a sum, it is a sum, and it is sum may be complement or uncomplement. This is a product. Okay, na? So I'm writing first product. Okay, na? Product of sum. B plus is sum, A plus B bar is sum, A plus B plus C bar is a sum. Okay, na? This is a sum of products or product of sum. Okay, na? Okay, look at here, this is a finally what is the conclusion? So sum of products and a product of sum means okay. So sum of products and product of sum. So final one conclusion between these two I'll give you. So sum of products A, B, C bar, A, B, C or anything A, B, A bar, B, C. Okay, this is a sum of product. First we start at sum followed by the product. Clear? Next, product of sum. First you should keep products. You know, should keep products. Okay. Of sum nothing but A plus B plus C bar or B plus C A plus B bar. Okay, na? This is sum. It is a sum. It is a sum. Okay, na? And it is a product. It is a product and product. Okay, this is another sum of products and product of sum. Okay. Next, we are going to talk about canonical forms. Okay, canonical logic forms. So canonical form means what? Okay, na? Canonical logic forms. From the above term POS or SOP, we can realize that all the individual terms do not involve all the literals. For example, look at here. Okay, na? For example, look at here. This is a sum of products only. It is a sum of products, but It does not include all the literals. Literals are variables. So some of the variables are missed here. For example, look at here. Okay, na? Here I wrote A B C bar plus B bar C plus AB. It is a sum of product. What is it? It's a sum of product. It's a sum. It is a sum of a product, right? But here three variables are there here. Here two variables are there here. Here two variables are there. So one variable is missing here. AB is there, but C is missing. Here BC is there, but A is missing. Here three terms are there. The three terms are there. Okay, na? So any letters are missing means it is a not in a standard form or not in a canonical form. Okay, this is about this. When it is a standard form, but not all the literals. Okay, na? So it has three literals, two literals, two literals, but it is not a canonical form or not in a standard form. Okay, na? So all the SOPs are not in the canonical form, maybe in the canonical form or may not be in the canonical form. Okay, na? So from the above forms, POS or SOP, we can realize that all the individual terms do not involve all the literals. For example, consider, so just now I discussed, no, ABC and BC bar. Here A is missing. So ABC and BC bar, no, here three variables are there, but only two variables are there. But A is missing here. Okay, it is not in the standard form or canonical form, but it is nothing but a SOP, sum of product, sum of product. Okay, this is a product. Okay, so now how you convert a sum of products expression into canonical sum of form. Okay, now look at here. This that I'll explain through an example. Okay, now so he is giving that expression. It is a sum of product, but not in the canonical form. How? Okay, now why it is not in the canonical form? Because here AC is there, AB is there, BC is there. Okay, now how many variables are there? A is given, B is given, C is given. So this expression contains three variables, but here AC bar is given, but B is missing. AB is given, but C is missing, and BC is given, but A is missing. Okay, na? So it is not in the standard form or not in the canonical form. So what is the canonical form? All the literals must should be there. Okay, na? So that is the canonical form. So how do I convert SOP into sum of products into standard form or canonical form? So see here AC bar plus AB plus BC. Okay, na? Here AC bar into 1 plus AB into 1 plus BC into 1. Okay, na? So why I am writing 1? Because so here B is missing. No, in this case B is missing. So B plus B bar equal to 1. No, B plus B bar. So I can multiply AC into B plus B bar. Why I am writing B plus B bar? Because in this expression B is missing. So I need to include B because each and every term must have three variables. This term must have, min term should have three variables. It should have three variables. It should have three variables. Hence I need to include B in this. Okay, now similarly, I'm gonna AB into here. What is missing here? C is missing. In this case, C is missing. That's why I'm writing C plus C bar plus here. What is missing here? A is missing. Okay, now that's in this A is missing. So BC into, right, A plus A bar. Okay, na? So finally, so I'm going to multiply everything, then you'll understand, right? First take this term AC B plus AC B bar. First I am multiplying AC B and then AC into B bar plus ABC, right? ABC plus and AB ABC bar plus, look at here, BCA. So means ABC plus and BC into A bar. So A bar BC. Okay, na? So finally I am arranging all are in order. So as per alphabet, A B C plus A B bar C. First B After that C I am writing plus A B C plus A B C bar plus, so after that again A B C plus A bar B C. Okay, now so this is the equation we got. Clear, no? So after that we should look at here like this. So here ABC is common here, ABC is common here, ABC is common. Okay, now so that's why we should write only once, one ABC only, because what is the formula I used here? A plus A equal to A, or A plus A plus A plus is also A only. Okay, that's why I wrote this. Okay, that's why I'm writing only once. Is there any A B bar C? A B bar C is not there. Okay, now this I should write compulsory. A B bar C plus A B C bar is there? No. A B C bar is also not there. A B C bar plus and A bar B C. Okay, now A bar B C is there. So this is my final answer. It is in standard form or canonical form. See, look at here. This is AC bar is there, but here B is missing. No, that's why I included B here. So each and every term, right? Each and every term should has three variables, because so here A is given, right? B is given, C is given. That is what you should understand. It is a three variable expression. Each term must have a three variables. Okay, now what are the missing terms are there? We are going to add that. Okay, now so here this term has three variables, this term has three variables, this term has three variables, and this term has three variables. So this is nothing but a standard canonical form. Okay, now finally it is the answer. Okay, now thank you very much.